Hello and welcome back to Calculus 2, the section 7.5, partial fraction decomposition. Probably it's going to be part 1 and part 2 because you only have 45 minutes now. So, you might recall from Algebra 1 that you have, say, 3x minus 2 plus 5 over x plus 3, say. And the question said add. In which case you would find the common denominator, which was x minus 2x plus 3, and then cross multiply, combine like terms, and be done with the problem. Now we're moving on all the way to calculus, and you encountered a problem that says integral of 8x minus 1 over x minus 2x plus 3 dx. And clearly U substitution doesn't work, integration by parts doesn't work, trigonometric substitution doesn't work, the black magic doesn't work. So the only thing that you can do is to somehow know that this is equal to the integral of 3 over x minus 2 plus 5 over x plus 3 dx, and then use U sub on each one of these separately to get ln of 3 ln x minus 2 plus 5 ln of x plus 3 plus c. The question is, how do we get this? So we know in algebra how to go forward, which is addition of rational functions. Going backwards is called partial fraction decomposition, and it's a procedure that you learn. It's the algorithm. You learn the entire algorithm, and you perform it every time when you run into a problem like this. Now, when you see something similar, it is worthwhile investing time to make sure that it's not a basic U sub, right? So be careful of that, right? There's no reason to use partial fraction decomposition if the U sub can solve the problem. Let's see this procedure of partial fraction decomposition. So we are going to memorize, there's no going around this, you have to memorize this, 4 situations that you will you're going to run into to set up partial fraction decomposition. So I abbreviate a little bit by writing blah over x minus c. That's the linear part. The setup is going to look like this. It's never important what's in the numerator, which is the reason why I write blah. And it also helps you remember because it's funny. So the next one is the repeated quadratic term. Sorry, linear term. Then we have a situation where we have a quadratic that you cannot factor any further. Whose setup is going to be this. All of this is obviously summarized in the textbook as well. And the last one, the fourth one, is the repeated unfactorable quadratic. I spent a few seconds to see the symmetry between the formulas. Note that denominator always has 1 degree x higher than the numerator. Over here, no x, or x to the 0, x to the 1, x squared, right? That's one of the features. Note that when you have the repeated one, it's the same, so it's the next constant. And the same thing happens here. Denominator is the same, squared, and it's the next constants, right? So they're highly symmetric, and you have to memorize this in order to be able to set it up. Now, to use this is just a whole bunch of algebra. So let's take a look at it. So I want to use the partial fraction decomposition on the 8x minus 1 divided by x minus 2x plus 3. Your denominator might not be factored, so you will have to factor that. In this case, it's factored, so it's easier. What do I have? I have two different factors in denominator. They're both linear. Therefore, the setup that I'm using is linear. So x minus 2 will get a constant a, and the x plus 3 will get a constant b. And all I need to do is to figure out what a and b are. Now, the only thing that I can do here is to add these two fractions, which means common denominator, which means multiply everything . And now, if you compare the first fraction and the last fraction, note that they are the same, right? Because equal sign in between. And note they have the same denominator, which means that the numerators must be the same. And now, what we do is we factor out x. So we get a plus b x plus 3a minus 2b is equal to 8x minus 1. Color coding. Coefficient of a, coefficient of x, and constant. They have to be the same. So from the red equation, I get that a plus b is 8. And from the blue equation, I get that 3a plus minus 2b is negative 1. This over here is the system of equations. So solve it. Multiply the top by 2. Solve it any way you know. I am not imposing any method. Whatever works for you, use it to solve it. So that is the trick. You get your A, you get your B, and you place them above. So A above x minus 2, and 5 above x plus 3. And now if I go all the way to the beginning of the problem, yep, see, that's that. So that is partial fraction decomposition. it is not calculus. It's algebra. But without it, we can't integrate certain problems. So we take the problem, we factor the denominator, we use the setup to set it up, then use the eventually system of equations to get the ABC, and then you use U sub or inverse trig, right? There has to be, after that, something will be done. Once I ran into this insane problem where I had to use completing the square to get it into the form for partial fraction decomposition. And when I did a partial fraction decomposition, one problem from there was ln, one problem was trig sub, so I had to do it again, right? And then one problem was something else. So what I did with the original problem is I put that problem into product rule and created that you actually have to start in with integration by parts. So technically, combining almost all of the rules that we learned in one problem. And I can't find it anywhere. I can't find it. I was so happy when I crafted that thing. Now, I crafted that as a student, not, it's been 10 years. And I can't find it anywhere. So if I find it, obviously, I'll give it to you. What do you mean, no? Sharing is caring. Okay. So here is the first example that we are going to integrate. We have time, I hope. 3x squared plus 7x minus 2. What happened? Well, the question is, can you factor the denominator now? Where do we start in factoring? How's your algebra? So pull out x first. Okay, fine. And then what do I do with the rest? Thank you. See, this is, I'm going to just write this 15,000 times. So what did you say it was? Beautiful. How many terms do I have? 3. So how many setups do I have? 3. And they're all linear, right? So A, B, C. Each one gets one. X is also linear. It's like x plus 0. Think of it that way, all right? So the single x gets its own A, x minus 2 gets B, x plus 1 gets C, and then from there, 30 minutes of algebra. Let's go. So the setup is integral, open parenthesis, A over x plus B over x minus 2 plus C over x plus 1 dx. Great. All right, common denominator. A over x plus B over x minus 2 plus C over x plus 1. We need to get the common denominator. Right, it will equal 3x squared plus 7x minus 2. All right, so the first one is missing x minus 2x plus 1. The second one is missing x plus 1. And the third one is missing, x minus 2. So now we don't have to bother with denominators because both sides will have a common denominator. We just have to worry about numerator. So we have to FOIL and multiply A, then FOIL, multiply B, FOIL, multiply C, and then we'll collect like terms and do all of the other stuff later. X times x is x squared, so ax squared. Plus x, and then minus 2x is minus ax. Minus 2 times 1 is minus 2a. So I FOIL, and then I multiplied everything by a. Plus bx squared plus bx. When you distribute x, you get x squared plus x, then times b each. And plus cx squared minus 2cx equals to 3x squared plus 7x minus 2. Combine all x squares, combine all x's, combine all constants. Color coding. X squares, blue, x's, and green, constant. So I have red equation, a plus b plus c is equal to 3. I have a blue equation, negative a plus b minus 2c is equal to 7. And I have a green equation, negative 2a equals negative 2. System of equations. Well, luckily, the bottom one gives us that a is equal to 1. And that greatly simplifies everything else. So b plus c is 3 minus 1 is 2. And b minus 2c is equal to 8. You can subtract these two equations to have b minus b is 0, c minus negative 2c is c plus 2c, which is 3c. And 2 minus 8 is negative 6. So we immediately have that c is negative 2. And because b plus c, so minus 2 equals 2, b is 4. So I have the integral of, so a was 1, that was over x, so 1 over x, plus b is 4, what was under b? X minus 2, and then x plus 1. Minus 2 over x plus 1. You know when I weep every time? When you do everything correct up to this point, and then you put A, B, C in the wrong spots. See, number 4 is B, and B is over x minus 2. They all have to line up. Because if you swap them, the whole thing is wrong. Yep. Okay. So now I have integral of 1 over x is? Yep, ln absolute x. And then plus 4 ln of x minus 2. And then minus 2 ln of x plus 1 plus c. Welcome to partial fraction decomposition. I think I just set a record. That's okay. I got you. On the exam, I have two problems for partial fraction decomposition usually. One problem is, I would call this a simple problem because we did it fairly quickly. So it's either two variables or easy three variables. This is considered easy three variables because 3 by 3 system will solve instantaneously. This is how much it took. Remember when you have 3 by 3 system, you have to spend like a whole page to solve that. Right, so this is considered easy one because you got one for free and then reduces it 2 by 2 and then you're done. So one problem on the exam is going to be pretty much like the one of the two we already did, right? But the other problem is going to have a lot of factors and it's mainly a setup problem. So it will say setup, you don't have to solve. It says setup.
I got a quick question. What happens if you don't get the one? Like basically, make all three equations like equal to, like make two of them equal to each other, then use that one variable that I solved for.
Oh yeah, you can solve it any way you want. You have to solve some equation. Which way you solve it is governed by your previous education. Everyone learns how to solve this equation in a different way. So some of you might use matrix. Some of you might use the elimination method. Whatever you guys are comfortable with. Because, sad to say, I don't care which way you solve it, right? It is, it is what it is. I'm not interested in your algebra and which way we're going to take care of this. What I'm interested in is having the integral in the beginning and having this answer at the end. I know you have to use partial fraction decomposition because there's no other way. Now that entails system of equation, and which way you're going to solve that depends on the previous education, right? Who taught the course previously, right, and so on. Yeah. Let's take a look. Next one. So beautiful example, 28. 16x squared divided by, it's already factored for you, x minus 6, x plus 2 squared. So this would be it for tonight. I'll give you 7 minutes to see where you can get with this. that? Yeah, 1 second. Setup. The repeated one. Look at the setup for the repeated, right? The one that is repeated has the without the square, and the next one has the square. So that's why you're only missing x minus 6. Wait, so this one should have had a C. There should be a C here. Well, no, this is only for this one, and then you have one piece. So this is not the setup. No, you have to have erase the square, and then put plus C over x plus 2 squared. Okay, so now you erase this. So this one and this one have setup number 1, setup number 2. This is pretty much setup number 1. This is setup number 2. Okay. There are two different features. So we are mixing now two setups here. We have a linear setup and a linear repeated setup, so you are ending up with 3 terms. Seconds left. let's take a look together. So I will have a times x plus 2 squared plus b times x plus 2 x minus 6 plus c times just x minus 6. That's the only thing that's missing, and all of that needs to be equal to 16x squared. So we have ax squared plus 4ax plus 4a plus bx squared minus 4bx minus 12b plus cx minus 6c equals to 16x squared. So now, again, color coding with the x squares. That gives me a plus b is equal to 16. The blue equation is the one that has x's. And I have 4a minus 4b plus 1c is equal to 0. There is no x term on the right-hand side. And the green one, 4a minus 12b minus 6c, again equal to 0 because there is nothing on the other side. So now this is more complicated system to solve than what it was earlier, right? We don't get a one variable for free. So what do? Well, we eliminate c from these two equations by multiplying top by 6. So copy a plus b equals 16. And we multiply the top equation by 6 and we add equations, and that will kill off c. So 6 times that's 24 plus 4 is 28a. 6 times negative 4 is negative 24 minus 12 is negative 36b. And then 6c minus 6c dies equal to 0. Now these equations, we can actually cancel this one by 4 to make it easier. So a plus b equal to 16. And when you cancel by 4, you get 7a minus 9b is 0. You can multiply top by 9 if you want to, and that kills b. So 9 times a, that's 9, plus 7 is 16a. 9b minus 9b dies, and over here you have 16 times 9. And I don't want to compute that because if I divide both sides by 16, I get that a is 9. If a is 9, b must be 7 because they add to 16. And then we figure out c. So 4 times 9 minus 4 times 7 is equal to negative c. So if you calculate this cleverly, you see that this is 4, 9 minus 7, which gives you 8. So negative 8. And there we have it. So its integral, a is 9 divided by x minus 6. Plus b is 7 over x plus 2. And minus 8 over x plus 2 squared dx. What now? Great. That's all correct. And then we get to the third one. You sub. You okay? All right, so the entire problem looks like 9 ln x minus 6 plus 7 ln x plus 2 plus 8 x plus 2 plus c. There we go. So we'll continue tomorrow with more exercises and more complicated, far more complicated setups, which we will not be solving because we have computers for that. But as I said, the one problem is going to be something that you can compute during the exam in about 10 minutes or so, and then there will be a problem that you can set up in a minute, right? Which will be an hour to solve by hand with 6 variables or something like that. So we'll take care of that tomorrow. We don't solve them, we just set them up. See you all tomorrow.